Sri Ganeshaya Namaha. Students, we have been solving practice set 6.1, page number 131 of Maths 2, that is geometry. Especially we are doing trigonometry. From question number 6, we have solved example number 1 and 2, and now today we are going to see example number 3. Prove that under root 1 minus sin theta upon 1 plus sin theta is equal to sec theta minus tan theta. Now whenever we are attempting the problems of the type prove that, either we can start from left hand side and go on simplifying. If we reach right hand side, well and good. We may start from right hand side, go on simplifying, and we may reach left hand side. That is also well and good. Or the third option is, you may start with a left hand side, and even though you are not reaching right hand side, you are doing something and you are reaching some step. We can number it 1. You can start simplifying RHS, go on simplifying, you are getting some step 2, and then you can compare 1 and 2. They may be identical, or from 1 you can go to 2, and from 2 you can go to 1. These are the different ways of proving. Here I have selected the way of starting from RHS and then reach to LHS. So here RHS is sec theta minus tan theta. This. Now sec theta means sec theta is equal to 1 upon cos theta. So sec theta I have replaced as 1 upon cos theta minus tan theta. Tan theta is equal to sin theta upon cos theta. So here sec theta minus tan theta I have written as 1 upon cos theta minus sin theta upon cos theta. Now LCM is cos theta, so it is written once, and numerator is 1 minus sin theta, that is written here. Now I am saying that I have to reach to left hand side. In the left hand side there is a radical sign. So I want a radical sign, so I have introduced a radical sign here, and instead of the original thing I have squared it. Instead of 5 I can write square root of 25. Instead of 6 I can write square root of 36. So I am squaring and writing square root. Because on left hand side there is a radical sign, I am bringing this. So 1 minus sin theta has become 1 minus sin square theta, and cos theta has become cos square theta. Now if you see left hand side, you don't want cos theta. So cos square theta can be replaced as 1 minus sin square theta. Cos square theta can be replaced as 1 minus sin square theta, because sin square theta plus cos square theta is 1. And therefore, this you can write as, this LHS you can write as, under radical sign, 1 minus sin theta square means 1 minus sin theta into 1 minus sin theta twice. And this cos square theta you may first replace as 1 minus sin square theta, and then this is the difference of 2 square, 1 square minus sin square theta, that is 1 minus sin theta and 1 plus sin theta. A square minus b square is a plus b, a minus b. Now 1 minus sin theta gets cut. So you are left with 1 minus sin theta upon 1 plus sin theta, and that is equal to LHS. That way you can prove. You may think over how to start from LHS and what step is to be done. You have to think what is to be done and why it is to be done. You will get the answer. Here you will find that on the right hand side you want sec theta minus tan theta. Means sec means 1 upon cos theta and tan theta means sin theta upon cos theta. You should be able to visualize this. That means you want 1 minus sin theta upon cos theta. But here there is no cos theta in denominator. So to get cos theta in denominator, you can think that original is 1 plus sin theta. If you multiply by 1 minus sin theta, it becomes 1 minus sin square theta, which is equal to cos square theta. So you are reverse way, if you go on writing, you will get from LHS to RHS also. Then from the same question, sub-question number 4, prove that sec theta minus cos theta multiplied by cot theta plus tan theta is equal to tan theta into sec theta. Now here, left hand side I am starting. Left hand side is equal to sec theta minus cos theta into cot theta plus tan theta. Generally, whenever you are confused, it is always advisable to write sec as 1 upon cos, tan is equal to sin upon cos, cot is equal to cos upon sin. Everything if you write sin and cos, generally the problem simplifies. So I am writing as sec theta as 1 upon cos theta. Then cos theta I am writing as cos theta upon 1. Cot theta means cos theta upon sin theta. And tan theta means sin theta upon cos theta. Now to operate this 1 upon cos theta minus cos theta upon 1, the LCM of the denominator is cos theta. And numerator you will get cross multiply. 1 into 1 is 1. And cos theta into cos theta is cos square theta. Here is minus sign. Similarly here, the denominators are sin theta and cos theta. So denominator is sin theta into cos theta. Numerator will be cos theta into cos theta, that is cos square theta. And sin theta into sin theta, that is sin square theta. The middle sign is plus, so it is plus. Now here, 1 minus cos square theta becomes sin square theta, because cos square theta plus sin square theta is 1. So 1 minus cos square theta, this cos square theta is brought to that side. 1 minus cos square theta is sin square theta. So sin square theta upon cos theta. And here sin square theta plus cos square theta is 1. So 1 upon sin theta cos theta. Now if you see the right hand side, it is tan theta. So here 1 sin theta will cut with 1 sin theta. 1 sin theta will remain. So this 1 sin theta and 1 cos theta. Sin theta upon cos theta is tan theta. So that you got. On RHS you want tan theta. And another is 1 upon cos theta. That is equal to sec theta. So you from LHS you started and you can get RHS. Okay. It may be difficult to start with RHS and get LHS, because RHS is very simple thing. LHS is slightly complicated. From simple to complicated is difficult. Complicated can be simplified to get simple. Now again, same question, question number 6. So question number 6 and sub question number 5. Prove that cot theta plus tan theta is equal to cosec theta plus cosec theta into sec theta. So here I am starting with left hand side, cot theta plus tan theta. Now cot theta means cos theta upon sin theta. So this I am replacing as cos theta upon sin theta. And tan theta means sin theta upon cos theta. So this tan theta I am replacing as sin theta cos theta. So denominators are different, sin theta and cos theta. So the LCM will be product of sin theta and cos theta. Denominator will be sin theta into cos theta. And numerator will become cos theta into cos theta, that is cos square theta, and sin theta into sin theta, that is sin square theta. So we have the identity cos square theta plus sin square theta is 1. So this numerator will be replaced as 1. And denominator is sin theta cos theta as it is. So now here if you see right hand side, you want cosec theta multiplied by sec theta. Cosec theta means 1 upon sin theta. So this if you split as 1 upon sin theta into 1 upon cos theta. 1 upon sin theta means cosec theta and 1 upon cos theta means sec theta. Go on writing these steps also, so that you will remember this formulae. And in examination if you write this, examiner will not have any chance to deduct any mark. Okay. Then again next question. From question number 6 we are doing sub question 6. Prove that 1 upon sec theta minus tan theta is equal to sec theta plus tan theta. 1 minute. I wanted to say something about previous also. This sum can be done in other several ways also. Okay. We shall discuss it separately. Cot theta plus tan theta. This is simple method I have given here. Cosec theta into sec theta. Another method would be you start from the left hand side and forcibly you take the cosec theta out from both the terms and see what remains in the bracket. Okay, whatever remains in the bracket, that should simplify to sec theta. Otherwise, second method would be if you start from left hand side and possibly if you take sec theta common from the two terms, whatever remains inside will be simplified to cosec theta. Now here, this also 1 upon sec theta minus tan theta is equal to sec theta plus tan theta. This also can be done by several ways. So if you recollect the identity relating sec and tan, 1 plus tan square theta is sec square theta. And therefore, this tan square theta, if you transpose to that side, it becomes sec square theta minus tan square theta is 1. Now, the factors of sec square minus tan square, you can treat as a square minus b square. A square minus b square is a plus b, a minus b. So, this is sec theta bracket square minus tan theta bracket square is equal to 1. So factors are sec theta plus tan theta, sec theta minus tan theta is equal to 1. And therefore, if you want sec theta plus tan theta in numerator, so other term you transpose to that side. Sec theta minus tan theta, if you transpose to that side, this being a factor here, it will go in denominator. Sec theta plus tan theta is equal to 1 upon sec theta minus tan theta. This is one of the proofs. Finally, you can write whatever is asked. So here, this 1 upon sec theta minus tan theta was on left hand side. You can write on left hand side. And sec theta plus tan theta you can write on right hand side. Another way of doing this is start with LHS, multiply numerator and denominator by sec theta plus tan theta. Now here you will see that if you start with LHS, that is 1 upon sec theta minus tan theta. You multiply numerator and denominator by sec theta plus tan theta, sec theta plus tan theta. The numerator will remain sec theta plus tan theta, which you want, and denominator will become sec theta minus tan theta multiplied by sec theta plus tan theta is a minus b, a plus b. That is a square minus b square. Sec square theta minus tan square theta, which is 1. So we are getting right hand side. That is what is written here. This can be done in several other ways also. As I told you before, whenever you are slightly confused, you can write sec as 1 upon cos, tan as sin upon cos, simplify left hand side. Write sec as 1 upon cos, tan as sin upon cos, simplify right hand side. You may not get them same, but again you can think slightly and adjust them to get them same. Next is example question number 6, sub question number 7. Prove that sin raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. We will find that in left hand side there is sin theta, but on right hand side sin theta is not there. So you have to get rid of sin theta. For that you know that sin square theta plus cos square theta is equal to 1. So sin square theta can be written as 1 minus cos square theta. Left hand side is contains sin raised to 4 theta, that is sin square theta square. Okay, so that will be useful. So you can write the left hand side as difference of two squares, sin square theta bracket square minus cos square theta bracket square. This is treated as a square minus b square. The factors are a plus b and a minus b. So this is your a, sin square theta is a, so a square, and cos square theta is b, so this is b square. This is a plus b, a minus b. Now as I told you here, sin square theta plus cos square theta can be replaced as 1, and this sin square theta I am replacing as 1 minus cos square theta. This is 1 minus cos square theta, and this minus cos square theta as it is. Here I have used that sin square theta plus cos square theta is equal to 1 here, and also for this sin square theta I have used as 1 minus cos square theta. So same identity has been used in two places. Now here 1 multiplied by anything you want, so this is to be ignored. 1 minus cos square theta minus cos square theta is 1 minus 2 cos square theta, that is RHS. Question number 6. Sub-question number 8. Prove that sec theta plus tan theta is equal to cos theta upon 1 minus sin theta. This is what I was telling you before. Sec theta plus tan theta. If you start from right hand side, sec theta plus tan theta, you may simplify it to get cos theta upon 1 minus sin theta. And if you simplify this left hand side, you may get something like that, and then you have to show that they are equal. That is also another way of proving this. So here left hand side is sec theta plus tan theta. Sec means 1 upon cos theta. You can write here sec theta is equal to 1 upon cos theta, and tan theta means sin theta upon cos theta. Here LCM is cos theta, and numerators are 1 plus sin theta. So 1 plus sin theta upon cos theta, that is you got. Now you are asked to complete it. There are two methods are suggested. Multiply numerator and denominator by cos theta. You will ask why it is to be done like that. Because on RHS you want cos theta in numerator, which is not here. So if you multiply this by cos theta upon cos theta, so whatever cos theta you want, this will be helpful to you. And other things we can see that they will cut. So this will simplify to cos theta into bracket 1 plus sin theta upon, this is cos theta into cos theta is cos square theta. Cos square theta can be written as 1 minus sin square theta. So here this will simplify to cos theta into bracket 1 plus sin theta upon 1 minus sin square theta can be factorized, a square minus b square. So 1 plus sin theta into 1 minus sin theta. So 1 plus sin theta gets cut, and you are left with cos theta upon 1 minus sin theta. So that is what you want here, RHS. This is method 1. What we have done, after reaching here, we saw that we want cos theta in numerator, which is not here, and therefore we are multiplying both by cos theta upon cos theta. Then cos square theta is simplified as 1 minus sin square theta and factorized, which cuts the factor 1 plus sin theta, and we get the required answer.